policy. That is not university policy. That is legal privacy issues. Okay, so you want to get in a conflict with the federal or state government, that's on you. All right, you've been warned. Okay. Okay, be sure all relevant Windows files are closed. You should just have a blank Mathematica file. You don't even need a Mathematica file. Basically, everything should be closed. You may have to, other than Outlook, and to be able to download a Excel workbook, Excel spreadsheet. Other than that, you don't even need Mathematica. That's because we are not going to be doing a Shapiro-Wilk test on this one. We may, in the future, we certainly will on the final, probably on the sixth quiz. This one, we're not going to be doing a Shapiro-Wilk test. Okay, so you don't have to worry about that. Know how to do a hypothesis test for two means, paired, unpaired equal variance, or unpaired unequal variance. First question, do your data have more than 30? Does each of your data sets have more than 30 data points? If yes, you use a z-test. If either is below 30, you use a t-test of some way, shape, or form. Next question, is your data paired? Data meaning that, first of all, if you do not have the same number of data points in each case, they cannot be paired. So if you notice a different number of data points in each of your samples, you don't even have to think about it. It's not going to be paired. If they have the same number of data points, then you have to think about it. Is there a natural correspondence between those two numbers? Okay, so then you determine whether it's paired or not. Now, if it's unpaired, you got to say to yourself, do I want to assume equal variance or unequal variance? And our current approach, and I have a feeling this may or may not change over time, but if it's changed, I am unaware of it. But the overwhelming approach is either A, the nature of the problem. Nature of the problem always has precedent. Okay, if the nature of the problem compels you to believe in equal variance or unequal variance, you do that, right? But if the nature of the problem doesn't tell you either way, then we're using an F-test. If equal variance is reasonable, we'll assume equal variance. If equal variance is unreasonable, we will not assume equal variance. And we will do that using the f.test command. Now, do not use the f-test via data analysis. The reason being, the f-test via data analysis gives you a one-sided f-value, one-sided p-value rather. Why? I have no idea. I don't know why they want to give you a one-sided p-value. It doesn't make any sense, but they do. Okay, the f.test command will give you a two-sided p-value, and that's what we need to know. It's a p-value for equal variances. So can we assume equal variances? So if the f.test command gives you a value over 0.05, we're going to assume equal variance. Less than 0.05, we're going to assume unequal variances. Be able to do a chi-square test for independence using a 2x2 table. That's the same thing as looking at P1 minus P2 equals 0 versus P1 minus P2 not equal 0. If you're dealing with a one-sided test, you basically would double your alpha value in the chi-square test, and you should be fine. Know how to calculate the odds ratio. The odds of is the first three words you will always write for an interpretation of the odds ratio. If you have a question on the odds ratio and you draw a complete blank, you have no idea what to do. Writing down the odds of for an interpretation will give you at least a point. Okay, so better 1 point than 0 points, right? So the odds of will give you a point. So for example, if we have something like this, the odds ratio would be 80 times 60 divided by 60 times 30. The expecteds are calculated by the row sum times the column sum divided by the grand total. There are two possibilities for any of these questions. I could give you the question along with a test stat and a p-value and any necessary or relevant information, and then you have to figure it out. Or I could give you an Excel, or I can have you do it all in Excel from start to finish, basically, in which case you're going to have to get all this stuff. Assume there might be a mix of both. For a chi-square test, I will in all likelihood give you the expected. No, I'm going to say if you have a chi-square test in Excel, I would give you the expecteds. Why? Because if you mess up the expecteds, I'm not going to have a clue as to know whether or not you know what you're doing from there. Okay, so if the expecteds are mixed up, you might have the rest of it nailed perfectly. I won't. There's no way I'll be able to figure it out. Right. So if I give you the expecteds, I can pretty much figure out what went wrong when you did the analysis. If you mess up the expecteds and you made a mistake after that, I have no idea how to catch that. Odds on if I give you the expecteds, or if I put this on the written part, I won't give you the expecteds. Or I might say you can assume all expecteds are bigger than 10 or whatever. If I don't give you the expecteds, or if I do in the computer part, it is fair to ask you to calculate one expected or verify a calculation on one expected. So then you would go through the numbers to give you the answer. So for example, where did this 67.2 come from? 140 times 120 over 250. So again, you should be able to calculate expecteds. I'm not going to have you do all four of them, because if you can do one, you can do four. So just being able to do one should be fine. Okay, so let's suppose we have two versions of something and we have a different success and failure rate. We could say P1 minus P2 equals 0, or P1 minus P2 greater than 0. If we're taking this approach, we'll change the alpha to 0.1. Because this is a one-sided test, we should double our alpha value to compensate for that. If we're doing just independence, we could leave the alpha at 0. Well, no, either way. If we used a chi-square test and a chi-square dot inverse test, we would get our p-value and our test stat. And we could figure out our hypothesis. In this case, we would reject because we doubled our alpha, and we would determine that variance 1 is the success rate under the first variation is greater than the success rate under the second variation. Now, I'm not going to give you a situation where you have to worry about doubling the hypothesis, but it's something that should be mentioned and should be known going forward. But it's kind of a tricky kind of a thing, so it's not going to be on a test that way. It's going to be clearly less than either alpha you would choose, or clearly above whether you would double the alpha or not. But again, it's just something you have to be conscious of in a real life situation. Use a t-test. We always assume normality. Okay, when we have less than 30 data points, we will always assume normality in this class. Whether or not we use a t-test when we don't know the standard deviation, or we know the standard deviation, in which case we'll use a z-test. You really have to assume normality. Otherwise, it's going to be difficult. We don't need assumption for z-test. We don't need assumption for Shapiro-Wilk, even though Shapiro-Wilk will not be on this quiz, but it might be on future quizzes. For chi-square tests, or for comparing probabilities, we want our expecteds to be greater than 5. Sorry, we need the expecteds to be greater than 5. We want the expecteds to be greater than 10. Less than 5 is a big problem. Between 5 and 10 is kind of a debatable thing. Greater than 10, everyone agrees, we're good. Okay, so let's suppose an environmental group compares the amount of pollution in 7 New Jersey beaches in 2023 and the same seven in 2024. If the p-value is 0.0032 and the test stat and f-test is 0.1045, determine whether the beaches were more polluted in 2024. Okay. What type of test are we using? Are we using a z-test? Yes, no, why? Are we using a z-test? Who says you're shaking your head? You say no. Why? Why would you say no? Less than 30 data points in each case. Okay. Paired or unpaired? What do we think? Go ahead. Paired. Because the same beaches, correct. Now, if we did one set of beaches in 2023 and another set in 2024, then it would be unpaired. But since we're using the exact same beaches, it would be paired. Okay. The f-test in this case is irrelevant, but if I didn't put the f-test in there, if I said the f-test is irrelevant in this case, pretty much tips what the answer is. Degrees of freedom equals 6. Why? Why 6? n-1 or m-1, yes, or 7 pairs. We have 7 pairs in total. Subtract 1, we got 6 pairs. Oh, sorry, we got 6 degrees of freedom. Alpha 0.05. H0 would be mu 24 minus mu 23 is equal to what? 0, because we're saying the pollution's the same. Okay. Mu HA is going to be mu 24 minus mu 23. It's either going to be greater than, less than, or not equal to. Which of them? Which one? Greater than, correct. What's the key word? More polluted. And again, assume I'll give you the test stat. I'll give you the p-value. We would reject here, correct? Why are we rejecting? P-value is less than alpha. Our conclusion would be correct. I believe, I assert, there's compelling evidence, there's significant evidence, sufficient evidence, however you want to phrase it. If we fail to reject, then you would say it is reasonable that it hasn't increased. It's reasonable that it's the same. I have had students say it's reasonable to believe there's not enough evidence to say that it has increased. That's redundant, okay? That's like saying a dead corpse, okay? You don't have to say both, all right? You just have to say one or the other. I don't have a problem with it, but your English teachers might get upset by that, right? So again, either say it's reasonable to believe they're equal or there's not enough evidence to claim they're not equal. You don't have to say it's reasonable to believe that there's not enough evidence. Either there's not enough evidence or it's reasonable to believe.
Test. Second one.
Where are we? Oh, yeah, pair test. Pair test. Pair t-test. Well, I'm sure there is a paired z-test, we just don't Use it. Reassert. Be able to do a chi-square test for uniformity. That's unlikely, but not impossible. Question. Okay, a paired test, we're only worried about the difference is normal. Unpaired test, both data sets are normal. Z-test, we're not worried about it. Okay, what's the primary purpose of Benford's law? Well, that's what it's doing, but what's the purpose of doing that? Why are we going to bother applying Benford's law to a set of data? Right, it's to detect data fraud. And again, it's not so much know as suspect, but again, if it fails Benford's law, it's not a guarantee it's made up data. If it passes, it's not a guarantee it's not, but it certainly shifts you in one way or the other. It's certainly a flag. If you have a ton of data set that you want to go through to see if there's any that might be made up, it's a nice filtering system. And you focus more on ones that fail Benford's law and then start doing further investigation. Because you don't have time to investigate all of them. Okay. Okay, let's do. There we go. Okay. Two methods are being considered. Two groups of patients are subject to different treatments with the given results. Determine if there is sufficient evidence to believe the first treatment has a faster recovery time than the second. Justify your answers. Okay. But alpha equals 0.05. Typically for medical problems, 0.01, but we specifically said 0.05 here, so that's what we're going to work with. Okay, MN, Z-test or not Z-test? Not a Z-test? Paired or not paired? Not paired. Do we even have to think about that one? No, because we have different set of data points. You can't pair, if you have 24 cups and 20 saucers, you can't pair all the cups and saucers, right? So you can't pair all the data if you don't have the same amount. Test that, p-value, f-test. We're going to assume equal variance or unequal variance. Assume equal because our f-test is greater than 0.05. So we're going to use an unpaired equal variance test. Degrees of freedom, is it easy to calculate, yes or no? And if it's easy to calculate, what's the calculation? Go ahead. In this case, it would be, okay, so in this case, that number would equal? Right, so given these numbers, that would be 42. 42, of course, is the answer to the ultimate question on life, the universe, and everything, at least according to Douglas Adams. Complete the following hypothesis test, alpha 0.05. Both data sets are normal. HO, U1 minus U2 equals 0. U1 minus mu2 greater than, less than, or not equal to here. I don't know why it's blue here, but okay. Greater than, less than, or not equal to. Is there sufficient evidence to believe the first treatment has a faster recovery time? Greater than, less than, or not equal to. What's the key word up here?
Yes.
So this would be less than. Clearly not equal to, and that's the reason our test stat would be negative. If by chance you just switched it around and said mu2 minus mu1 is greater than 0, the test stat should be positive. Okay, but I wouldn't sweat that. So we get test stat minus 1.09, p-value 0.1415. Reject or fail to reject? Reject or fail to reject? Fail to reject because P is greater than alpha. It is reasonable to believe the recovery times okay. One thing to note, there are books which would put a greater than or equal to here and a less than here. That is not the approach we have. If you go off script, you gotta give me a citation. So if you decided to make that a less than or equal to for your HA, which again is not encouraged in this class, you would have to tell me based on based on the book I used in high school or something like that, you would have to cite it. Along those lines, unequal variance problems, you will get a fractional number of degrees of freedom, but you will not get that in Excel. So if you put on your homework a fractional number of degrees of freedom and you don't put a citation, it's going to be wrong, even if the number is correct, because you would have to explain to me you did the calculation for that. And as I said before, there is no intelligent reason to do that calculation. Excel will do it very quickly for you. But this is unpaired. Well, one, because you don't have the same number of people in both sets. Another is because there's no, patient number 5 in, the first treatment is not even connected to patient number 5 in the second treatment. Whereas up here, whereas the last one, if they're the same 7 beaches, then we went to Ortley Beach and we got data in 23, then we went back to Ortley Beach. So we're just trying to figure out how much pollution Ortley Beach either went up or went down. So again, the paired because each data point comes from 2 different places. Or each comes from the same place in 2 different observations of the same thing. Whereas again, these are completely different observations. A study is done to determine if human body temperature at noon is greater than human body temperature at 8 a.m. A group of 16 subjects group of 16 subjects, not a group 16 of subjects. Took their temperature at both times with the results given, determine if body temperature increased or decreased, or sorry, increased during those hours, alpha 0.01. Z-test, yes or no? No, 16 data points each in each sample. Paired or unpaired? Because it's the same person, right? It's the same person at noon as it is. So really what we are doing is we are just going to analyze the differences, the amount of change between those times. Degrees of freedom easily determined to be 15. Number of pairs minus 1. Differences are normal. Now, again, if you said both data sets are normal, I'd give it to you. And a lot of books have that assumption, but it technically is not necessary. You don't have to assume that the individual populations are normal, just that the differences are normal. HO, U noon equals U8. HA, U noon greater than mu. And if we go into Excel, we get a test stat. We get a p-value. I'm not going to sweat out with the p-value. I know it is less than 0.000. So I am going to put less than 0.0001. If you tell me, if you put 0.000 down, yeah, if it rounds to 4 decimal places, it'll be all zeros. You might not get a 0 to like the 7th or whatever. Technically, that's correct. It's probably not good form, but I'm not going to sweat that one out. If you give me the exact value, I'm okay with that. Just 1 second. The exact value is 10 to the negative 14th power, 1.2 times 10 to the negative 14th power. You don't have to write that down. Less than 0.00001 is fine. Question.
So you're saying you're.
If it's on the written part. Okay, if it's on the computer part, you got to figure it out. I just had done this problem already. If anyone wants to, I can show you how to do it. It is data analysis. We said paired samples for 2 means. Data input range is here. Data 2 input range is here. Alpha 0.01, not that that really matters. Output range is D1. And it's going to say I am writing over, that's fine. It does have a negative test stat. I used a positive. What did I put a positive or negative? I put the positive version because I have set it up as noon minus. I inputted the data in reverse order. So I guess strictly speaking, I should have put the noon time in first, then the 8 time. I put the 8 time, then the noon. But noon is going to be greater than. So I know it's going to be a positive test stat. Reject or fail to reject? Be less than alpha. there is compelling evidence to believe temperatures increase. Between 8 a.m. and noon. Okay. Question. No, I just probably correct it. As long as you had, as long as you have the mu1 and your conclusion was consistent. Now, if you had mu1, noon minus, sorry, mu8 minus mu noon is less than 0, that would be more consistent with the negative test stat. That would be better, but I'm not going to sweat it. Okay, then that is a mistake on my end. You are correct. Again, I'd correct it, but I don't think I'd take it off. But you are correct in correcting me. Okay. And I guess the way I have this set up, it should be like this. Now, I know a lot of times on homework, I'll mark something off which you might think is trivial. It doesn't necessarily mean I took a point off for it. Okay. And I mean, if I had to write out exactly how I took off every point on your homework, I'd never be able to get them back to you. Right. So if it sounds trivial, there's a good chance I didn't take it off. But if you made the same trivial mistake, like maybe 4 or 5 times, then I might take a point off. If you make the same idea of not of asserting H0, you don't assert H0, you say H0 is reasonable. If you don't assert HA, if you consistently do that, I might only take a point off the first 2 or 3 times you did it, but not all 6 or 7 times that you did it. So again, a lot of times the corrections are just trying to teach you better form, not necessarily substantive. And this would be an example where I wanted, I wanted to have it the right form, and you were correct in telling me I didn't, very, very diplomatically, but I would never take points off for something like that. Okay, especially if you wound up with the correct conclusion, because you had the right idea. But again, that's something where I might, and I'll put a negative sign here, just to make it consistent with everything else. That is something where I would just make a note of it or something like that. And if you wind up with 69.99 on the homework or something, it means I want you to see these trivial little notes, but there's no real points taken off. But if I just gave you if I gave you a perfect score, you wouldn't bother reading the notes. Okay, a study is done to determine if the two groups of athletes have the same weight. Test the theory based on alpha equals 0.05. Here is the data. There are, I think, 21 data points in each case. 21 data points in each case. So am I using a z-test? Paired? No, because there's no connection between one group of athletes and the other, okay? Unpaired equivariance? We don't know. We need an F-test. So when I do my F-test, I get .04476. So am I going to assume equal variance or unequal variance? Unequal. Are degrees of freedom easily determined? No. And the reason is the formula in this case is very complicated. It can be done, but it is not easy and not something I would ever expect anyone to do. Not something I would ever do unless I had to. Okay, unless someone says, Professor, your job is to like program and get the degrees of freedom for all these problems, and we need your assistance on setting up these formulas. Yes, then I might do it, but you'd have to pay me money, right? Because Excel, all kinds of software will give you the exact number. Excel just rounds it to the nearest integer, which is fine. Okay, so complete the following hypothesis test, alpha 0.05. Assumptions and concerns, both data sets are normal. HO, mu1 minus u2 equals 0. What do we think, folks? Not equal to, less than, or greater than. Those are the only three possibilities we have. Which one? How many people say less than? How many people say not equal to? How many people say greater than? How many people say splunge? Splunge is never the answer in this class. Okay? Not equal to. There is nothing in the question which suggests we think the first group or the second group should be the heavier or the lighter. Okay, so we're assuming unequal variance, we go data analysis, unequal variance. I have Y. And then I have Z. And my output isn't AB, AD. And there I have my answer. I have my test stat. And again, if you wound up with the positive version, it means you use 2, then 1. Not really an issue. It would be an issue if we had a greater than, but as long as we got our p-values right, we should be fine. Our p-value again will be less than 0.0001. Reject. Conclusion. We assert that the two groups of athletes have different weights. And there are the data. Determine if the data from given in problem 4 comes from a uniform distribution. And we might as well use alpha 0.05. Assumptions and concerns. Well, let's do it. First, I sorted the data. If you look at your original data set, it's unsorted. But if I sorted, I found out the smallest number was 1. The largest number was 20. So I wrote down the numbers of 1 through 20. I have a count if command. How much in column J matches a 1? How many match a 2? How many match a 3? All the way, how many match a 20? I have 220 data sets. I have 20 possibilities. 220 divided by 20 is 11. My expected is 11 in each case. Is 11 bigger than 10? Yes. Okay, 11 is bigger than 10. Therefore, I don't have to worry about any assumptions or concerns. So assumptions and concerns, none. The lowest expected is 11, which is greater than 10. HO. It is uniform. It is not. Okay. So I've got my actuals. I've got my expecteds. This is equal to chi-squared. Dot test. Again, this is a low probability problem, but I don't want to totally ignore the possibility. Bless you. I get my p-value. I got my test stat. Reject or fail to reject. Reject or fail to reject. Conclusion. What's that? Probably does. Well, I shouldn't say it probably does, but perfect 0.9 is well above. Fail to reject. means it's consistent with a uniform distribution. Yeah,
Oh, okay.
okay. The group of people were surveyed and asked if they smoked and if they had taken 5 or more sick days off during the year. Based on the table given, do you believe there is a connection between these variables? So alpha, we can make it 0.01 if we want to consider a medical problem. And actually, let me just make sure what I got for my alpha. Yeah. Calculating the expecteds, I get that. So none. All expecteds. All expecteds are greater than 10. H0. Smoking is independent of taking more than 5 sick days. HA, smoking is not. Independent of taking 5 or more sick days. Test that. P-value. Zero 0.0002. Reject P less than alpha. Conclusion. We assert there is a connection between smoking and between smoking and taking off 5 or less sick days. Find and interpret the odds ratio. The odds ratio is going to be this. $1.96. Again, folks, your primary mistake that is going to be made is not honoring order of operations. I say this because empirically that's going to be the most common mistake. Take my advice. Do the products separately. Do the multiplication separately. First, you multiply 184 by 190. Write that down, or if you're on a computer, store it in Excel. Then calculate 128 divided by 139. Write that down. Then do your division question. Because I have equality at 5. You could say more than 5, or you could say 5 or less. Okay, but if you said taking more, that's true too. Yeah. But the reason it's 5 or less is because this is 5 or less. If I had the equal sign here, then 5, it would be 5 or more. It would be fine. And up here, I have taking more than 5, but strictly more than. Okay, so interpretation begins with the 3 words. The odds of a non-smoker having 5 or less sick days is about twice the odds of a smoker. Having 5 having 5 or less sick days. Now, just to be clear, I'm comparing what's in the top left corner to what's in the bottom left corner. That's always my comparison. So smokers having 5, or sorry, non-smokers having 5 or less sick days versus non-smokers having 5 or less. I'm sorry, smokers having 5 or less sick days. So non-smokers versus smokers, because that's how I have it set up. So this divided by this. If I switched around my table, I would put it in a different frame. But as a table stands, that's the odds of what versus what. What's that? Because that's what's here, 5 or less. Less than or equal to 5. Because getting the special symbol in there is a pain. Okay? Which is non-smokers having 5 or less sick days. Yeah, non-smoker with the other smoker, right? Okay. Group of people are surveyed to see if they had taken 5 or more. You're right, 5 or less. Okay. Sick days this year. Again, that's kind of a trivial thing where if you messed it up, it wouldn't be that big a deal because we understand the, low amount of sick days versus the high amount of sick days is how we would probably say that. Okay. No, because I had HO. What's HO? HO. Well, no, I can either say more than 5 or 5 or less. Either one's okay. It's like saying, is there a relationship between treatment and success rate? I could also say treatment and failure rate, because if there's going to be one relation, there's going to be automatically the other. Okay, the odds of twice the odds. You don't want to say
That's it.
no, almost twice. Yeah, but you need the odds in the second part of the statement, which you didn't include. You need the specific word odds. In both. The odds of versus the odds of. Now, you could kind of switch everything around and say a smoker taking more than 5 versus a non-smoker taking more than 5. That would work, but you'd have to kind of switch everything around. You'd get the same answers, but you're better off just doing the problem as it comes to you. Verify the expected for non-smokers with 5 or let me make this smokers. With 5 or less. 6 days. Okay. So how would I do that? It would be, I need the sums. The sums are here. know why that's doing that to me. Can I do this? Yeah, there we go. Okay, so I would need to do the sums. And then I would do. Okay, why do I have that there? That shouldn't be there. That should be, oh, I've got the top one. Okay, non-smokers with 5 or less. So again, row sum times column sum divided by total. I'm not going to make you do that 4 times, but you should be able to do it once. If you can do it once, I'll assume you could do it all 4 times as long as you don't fall asleep on the problem. Because after a while, calculations get to be mind numbing, and it's tough to keep concentration when it's just very simple calculations. It could be on either. Okay. If it's on the, again, if it's on a computer part, I give you the expected. On the written part, I might not, but I would mention whether or not all expecteds are above 10 or below 10. Or I might say the minimum expected is in this particular area, calculate the expected, and then you'll automatically know whether or not all expecteds are above or below 10, because the minimum is the one you got to look at. So again, all kinds of variations on that, but again, it could be on either. Any one of these could be on either. On the written part, I'd give you like anything that you would need the computer for. On the computer part, you got to pretty much do it on your own. And again, software is making it more and more easy to get to grind through the math. The interpretation, though, is something that you're always going to need to understand. So that's why doing the interpretation is, doing problems where you don't have to do the grinding math, but then you have to interpret your results are valid and are valuable. Okay, any questions? Catherine, can I ask you a favor? If the updates are not on by tomorrow morning, can you shoot me an email? I'll try to get them out quick, but I got a lot to do today. So if I don't get them out, I'm volunteering you, or as one of my professors used to say, voluntold. You were voluntold to do something. But I appreciate if I don't get them out, if you just shoot me an email reminding me. I only want one person to do it because I don't want to go through 20 different emails. Okay, any other questions? Everyone's good. Everyone's fine. Okay. Everyone understands the homework assignment, which is due by 8 o'clock on Sunday night. Like I said, I did that once without setting a due date, and I got a prediction after the game was played, which kind of defeats the whole purpose of trying to rate the predictions. Go ahead.
We need anything or just give our answer?
I picked my 2 lucky numbers, 21 and 13. Those are my 2 lucky numbers, so I picked them. Or, hey, my birthday, when's your birthday? So if you put, August is, you put 26 to 8. Valid answer. 8's tough. I guess you could get to 2, but that's the valid. 8 is unusual, I should say. Not that hard, but there's a homework assignment where you have to predict the final score of the Eagles Lions game this weekend. Just the final score. Don't tell me who's going to win. That we're not going to get enough information. We will next week rank the predictions from best to worst. Only if you put them there. The serious calculations will come when we decide to order the predictions from best to worst. And that's the point. Okay, we want to explain. Now, there are a bunch of different ways to do this, but we're going to use the way a statistician will do it, and we're going to explain why the statistician does it this way. And the whole point, I could either just make the numbers up, or I could use live data and just kind of like get a feel for it that way. Okay, I will probably give a small Wawa gift card to the winner. Okay, out of my own pocket, so I'm not asking you guys to chip in money. And I don't think anyone's gonna argue with me for that being a prize, since it's not costing anyone anything. It's just my way of acknowledging. And again, we're only going to acknowledge the winner. If you want to if you have a bad prediction or second place or whatever, that's up to you, but the winner will be acknowledged, which I think, should work. Any other questions? All right, so let's